My name is Jurgen de Klerck. I'm business developer, mobile private networks 5G within Proximus Next, and my role is to, on one hand, we have to build the applications together with our partners and our customers, and on the other hand, yeah, of course, someone has to sell the networks. That will be me as well. So today we're gonna speak about private 5G private networks. And what's a private network? Well, you all know Proximus as a telco operator. And to become a telco operator, you need a basic infrastructure. You need to be able to connect with a network. And, oh, that's going very fast. Yeah. And to connect with a network, the first thing you need, of course, is devices. And the second thing you need is spectrum. And we at Proximus, we have the biggest spectrum in Belgium, so you're good with us. The third thing you need is the radio, and then the fourth, the most important thing actually, is the core network. And the core network is where we capture all the data and transmit it. So if you make a phone call, you get connected with a radio antenna, all data comes to the data center of Proximus, and then we transfer your call to someone else. So that's in a public core. However, the most important thing for enterprises is private networks. And today I have for you to present is David, and David is our vendor of private cores. So David is going to explain you from what a private core might bring to your organization. Thank you.
Oh, thanks. Can everybody hear me okay? Good, thank you. First of all, thanks very much to Jurgen and to Marlene Abraham and the team at Proximus that we've been working with for the last few years for this invitation. It's a terrific event, and the place looks really, really great. And I really encourage you to walk around and look at all the demos and visit all the booths. It's really mind-blowing for us to see how good an event this is. Let me tell you a little bit about us before we get going. Druid Software is a developer of core technology for the enterprise market, which means we don't really sell into public networks. We don't deal with networks with tens of millions of users like the Ericssons and the Nokias do. We focus on the enterprise sector. We always have. So we're able to provide core networks for networks with as few as 10 or 20 users, all the way up to hundreds of thousands of users. Our business space is business, enterprise, edge computing, fixed wireless, public safety, applications like this, where the bigger public network provider solutions are oversized and are not a good fit. All of our software is developed in Dublin, in Ireland. We're an Irish company. We have offices in Asia, the US, and Latin America, but everything is developed here in Europe. And we have over 5,000 networks deployed worldwide. That's a huge number if you're familiar with the numbers from some of our competitors. And that is because we are probably in this space longer than anybody else in the world. We started off the company 23 years ago. We brought our first private network platform, a 2G platform, to the market back in 2008, where we'd been approached. We're a software development company. We were approached by a company that wanted to put private networks on airplanes. In those days, a network core was something that came in 3 steel cabinets about this size, and you needed a forklift to get them off the back of the truck to bring them into your data center. We turned that into a software application, and that is what we have been doing ever since, through 2G, into 3G, into 4G, now into 5G, and even, whisper it, starting to talk about 6G already. And as spectrum, as Jurgen pointed out, which is one of the critical factors for delivering a private network, as spectrum has become more available, we have managed to go from guard band deck replacement projects in the Netherlands into on-ship and oil and gas projects, into military applications, public safety applications, and now we're enabling the whole Industry 4.0 Internet of Things solutions across the world. We work in many, many different market verticals, but I'm going to focus on a few today. So from the things you would expect, like oil and gas, like offshore wind farms, ships at sea, smart mining, into areas you might not expect so much, like education, hospitality, healthcare, but manufacturing, ports and logistics, and enterprise communications remain the big market sectors for us. Why do people buy our product when they could buy a product from a Nokia or an Ericsson? There's a couple of reasons. First of all, simplicity. Our solution is designed for people who are not cellular engineers, who maybe 2 weeks before they become the network engineer were the Wi-Fi guy, and now they need to run a cellular network. So our user interface and our training is all built around taking somebody who is not a cellular engineer, but making them capable to run a private network by themselves, at least for simple day-to-day tasks. With the managed solution from Proximus, of course, they can even take that problem away for you, but if you want to manage your own network, it's very simple to do with the Druid product. Secondly, functionality. We don't follow the 3GPP specifications letter by letter. Instead, we cherry pick the different releases to take the pieces that are crucial for business networks and implement them in our product, and exclude the pieces that are relevant for public networks. So this allows us to have release 17 and release 18 features, like 5G LAN, like location management, built into our core, sometimes years before any of our competitors build it into their products. Thirdly, flexibility. And this flexibility covers everything really. Technically, we're highly flexible in that you can deploy us on bare metal, you can deploy us on a containerized solution, you can deploy us on a virtualized solution, you can deploy us in the cloud, you can deploy us in a data center, you can deploy us in the back of a truck, you can deploy us in a backpack, you can deploy us on a Raspberry Pi. The software will work almost anywhere. There's nothing that we have found that is a real viable platform in the market that we're not working on. We have the standard x86 architecture, we also have an ARM architecture, so if you want to put it on ARM chips, we can do that. So highly flexible in terms of where we deploy, highly flexible in terms of how we work with our customers. If there's a feature that doesn't exist yet, or a feature that is coming but it's still being specified at 3GPP, if you want, we'll build it for you. You don't need to wait for the specifications. If there's a business case there, we will build a product for you. And finally, of course, value. We're priced as an enterprise product. We understand the importance of return on investment from the business space, so the products that we sell are really focused into your market and not the wider telco market. Allow me to go a little bit deep into the architecture for 1 second. This is the overview of the standard core. So you'll see it as the standard 4G and 5G network elements. We also have Wi-Fi elements that we're bringing into the core, so we have TWAG and TWAP right now, so you can also manage authentication onto your Wi-Fi network from our product. And as the next couple of generations of the product come out, we will put more and more Wi-Fi management into our platform as well. Why? Because we don't want to worry about whether something is 4G or 5G or unlicensed band or anything else. It's all about building a product that manages wireless networks for enterprise. We have a built-in IMS, so you can do voice natively on our core, and everything is built on a REST API. So if you want to take information from something that's happening in the network or something that's happening on a device connected to the network, we can do that with REST APIs directly into your operations management system or your business management system, your network dashboard, whatever you want, we can do that integration. We also, we also support data slicing, which is a key advantage of 5G over 4G and other networking technologies, which means that we can create separate virtual networks for different applications where you can configure uplink speed, downlink speed, different quality of service indicators, all of the 5QI indicators separately for each slice, and then allocate devices to that slice. So devices can be running side by side on the same network, but have a completely different performance characteristic in the network. We can also plug into your existing DHCP server, so we can make it extremely easy to integrate into the network that you already have, whether it's a wired network, Wi-Fi network, whatever else you have. We're used to going into environments where there's already a lot of infrastructure in place. They're brownfield from a data network point of view, so a huge amount of our development has been based around making it easy to fit us into what's already there. Again, that's why we're so flexible in terms of the hardware we run on, the environments we run on. We don't want to have to tell you as a business how to do your back-end architecture, how to change your IP structures, anything like that. What you have is what you want. What we do is we fit in with what that is. Now, talking about why private networks are important. This, I think, should be news to nobody at this point. Your business is a data business now. I don't care if you are a lumberjack cutting down trees, a farmer milking cows, you're mining, you're baking bread, you're making computer chips. Whatever you're doing, you are in a data business, and data is one of your biggest assets. So you should be investing in making sure that that data is secure, that it is moving effectively and efficiently around your network, that it's resilient, so that that data never stops flowing around your business, and that everything that you do is being done as efficiently as possible. And yes, there are all kinds of amazing new tools like artificial intelligence and digital twins and these things that are coming and have already started to deliver really impressive results. I think we're very much at the beginning of that. What we're going to see coming from AI-enabled business is really going to be amazing in the future, but all of this is ineffective if you can't get the data from where things are happening at the device, at the person, at the edge, and bring it into that data model. So you're a data business. And what we do is we help make the flow of data around your business as efficient and effective as possible. Now, what markets do we do this in? As I said earlier, there really isn't a market that we're not in. Everywhere where you're moving data around, and that is every business, there is a use case for a private network. We're strong in hospitality. We do a lot of networks in casinos. We do a lot of networks in shopping centers. Obviously with energy and utilities, huge amount of requirements for the flow of data and the automation of events in networks. But we're going to focus on a few verticals today. We're going to focus on manufacturing, healthcare, logistics, and media and entertainment. So going to manufacturing, first of all. Very, very interesting, very topical with Mr. Trump back in charge in the US. Always good to disrupt things. But when you think about smart manufacturing, about where manufacturing needs to go, it really is all about data. It's about data acquisition. So your IIoT sensors at the edge, environmental monitoring for power consumption, air quality, noise quality, water quality. It's about computer vision. The advances in computer vision means that you can now literally have eyes everywhere. If you want to make sure everybody is wearing their hard hat and their boots on the building site, simple solution. You want to make sure nobody is jumping over the fence and stealing some of your products, simple solution. You want to make sure there's no smoke coming out of ducting or piping when nobody is in the factory. There's a simple solution for that. Secondly then, when the data is collected, the data analysis has to happen. This is not our area, but we enable it to happen. So things like digital twins, like generative artificial intelligence, all of that depends on a data lake. You have to be gathering enormous amounts of data about all sorts of events, and the finer the granularity of the data you collect, the more effective those tools are. So you need to put more sensors out. So you need to have more devices feeding into the network. And finally, data-driven decision making. So this is really where the rubber hits the road in terms of smart manufacturing, where you are getting into fully automated processes, cobots, so people are now working side by side with robots in an environment which has health and safety challenges, which can really only be overcome by a very high-speed, low-latency network. And where you have people, as you can see right outside here, the augmented reality smart helmet. A few years ago, this was something like science fiction. Now it is very much a fact. It is a product that is nearly ubiquitous in some extreme environments like oil and gas in offshore platforms. It really is how everybody does business now. That you wear the helmet, you have the AR glasses, and you are connected from the helmet back to some guy who's maybe a year from retirement, doesn't want to get on helicopters anymore, so he sits in his office or he sits on his couch and he talks you through how to support the machine, how to service the machine, how to repair the machine. This is the paradigm for any sort of hazardous environment at the moment. So this is happening. The RealWear demo or stand outside is really interesting. Some of the connected devices they're doing are really fascinating. So when you think about a network for manufacturing, what is good, what is better, what is best? A good network, the minimum you should be looking for is you need 5 nines reliability. So whether it's the radio, the server, the power supply, anything failing to your site should not affect your data network. You should have complete resilience at the edge. You shouldn't, I believe, be putting everything in the cloud, because you lose connectivity to the cloud, you've lost your whole factory. You should have amazing coverage. So there should be no black spots. There should be nowhere where people say, don't go into that room if you're making a phone call because it won't work. There should be no place where your AGV gets to the border and then suddenly stops going from hall 1 to hall 2 because it can't attach to the Wi-Fi in hall 2. And so they all just stop there and wait. That should not be happening. Everything should be working all the way across the network. And mobility from area to area should be a given. Also going from inside to outside and outside to inside. Even possibly going from off of the campus, going down to the public network and coming off the public network into the private network campus. That I think is just good. That's what everybody should be striving for. Better would be if you can start moving away from having to do so much cabling in your factory. If you can start to take some of the Ethernet connected devices or the Wi-Fi connected devices, connect them to a wireless router and have that router wirelessly communicate back to the SCADA or to whatever system is driving them. To do that, that's always been very difficult because without getting into the details of it, cellular is a layer 3 communications protocol and all of those deterministic systems need a layer 2 communications protocol. How we have kludged that up in recent years has been with things called VPNs, where we fox the Ethernet switch to think it's on the layer 2 network. What Druid is doing right now is we are delivering 5G LAN, the deterministic network that can support Profinet and Profibus direct from our core without the need for implementing any VLANs, which will massively reduce the complexity of using your 5G network to also run your sensors, your switches, your valves, anything else in a production environment. So that is really a significant improvement on what's out there at the moment. There are really only a couple of module makers. Quectel is probably the leading one, and we are doing a cooperation project with Quectel to get their modules working with our core. Configurable up and downlink, so you want to be able to take every device, make it have a different uplink speed and downlink speed, so your cameras are going up and down faster than maybe your switches or your sensors. We can support that. Network slicing, I think, almost is no longer better, it's just good. Everybody needs to be able to do that. And you need to be able to decide what you're deploying at the edge, what you're deploying in the cloud, and how these two work together. What happens if one fails, what happens if the other fails. That is better. The best, we think, is where you get to an ultra low latency. What do we mean by ultra low latency? We're talking about less than 8 milliseconds round trip latency in the network. Where we have gotten is our core adds no more than 1 millisecond to any transaction in a network, in a round trip. Obviously, cabling comes into it, radio comes into it, the kind of use case comes into it to give you your round trip latency, but the part that we control, the core, I think we're pretty much industry leading in terms of that. Support for RedCap, which is the narrowband IoT of the 5G world, and support for time-sensitive networking. And right now, Druid is also involved in a lab project with probably the leading manufacturer of industrial devices and are working on bringing time-sensitive networking to reality in the cellular network. So that's where we are. That's really cutting-edge stuff, but that's where Druid is right now. So what does this all mean on the shop floor? Yeah, this is a little hard to read, but let's keep it high level. So collecting data to feed it into your digital twin. So your IoT sensors, your cameras, any activities like that, support for all of those, that's definitely a main factor. Connecting up the workers. So whether it's using the native dialer to make phone calls inside the network, or being able to treat each smartphone as an extension of the PBX, so that people can dial from outside, dial the factory's number and then dial 111, and the smartphone with 111 as its number will ring wherever it is on the factory campus. That's something we're supporting. Low latency is critical to support cobots and any kind of autonomous vehicle driving around the campus, because they need to see if a human walks in front of them, and they need to be able to stop, they need to be able to react. All of these things are already being delivered right now in various factories with our colleagues in Proximus. We've delivered a couple of projects here in the Netherlands. One is for, and I'm going to mispronounce this, Gert de Bakker, and Factory is the other one. Apologies for my heinous pronunciation in Dutch. So you can see this is not just theory, this is not just science fiction. These are applications that customers are buying today and deploying today in Belgium in the private network space. Moving quickly into healthcare, another huge area for automation, because when you think about healthcare, this is really just the business of moving data around. Somebody comes in to the hospital, they need to be identified, they need to be registered. If scans are taken, moving MRI or X-ray files around takes about 5 to 10 minutes on a Wi-Fi network, takes about 5 to 10 seconds on a 5G network. And instead of sending them to a desk where the doctor or the consultant has to go and find them and ask for them, you can send them direct to a tablet that the medical person is carrying around. You can even have the bed itself alert the nursing staff or the doctors about what is happening with the patient, so you can program it to alert you that, let's say, the patient has to move every 4 hours because their condition requires that they don't always lie on their back. Now the bed can tell you the patient is moving or the patient isn't moving. The bed can call a nurse to come in and move the patient by itself. Asset tracking. Apparently, the average nurse spends 1/8 of every shift looking for stuff. Things that have wheels, things that people just move out of their way or move conveniently to some other place, or they just open a door and roll it in there and close the door because it's in the way. The nurse comes along, she spends 1/8 of every shift looking for things that somebody moved while they were not there. This is very much my experience in my house too. I spend about 1/8 of my time saying, who moved my tie, who moved my bicycle. So if you can do asset tracking, if you can locate something to even within a meter of where it is, you can give yourself 12% more nurses in the hospital, which is something that the cost benefit of that is staggering. It's so obvious that this is the right thing to do. And this is something that you can do on the same network that you're enabling all of your critical comms, all of your sending of images directly to the nurses or doctors' tablets, that you're enabling patient communication. So if something happens in a hospital, very often the first thing you want to do is tell somebody, it's a boy, it's a girl, it's not cancer, whatever it is, you want to tell somebody. Very often the public network coverage in hospitals could be better. So by installing private networks, there's ways to allow public users to roam onto them to improve that public coverage. So you can make the user experience for the patients as well as the hospital admins significantly better. So huge applications there. Logistics and warehouses, obviously another huge business in the Netherlands. Again, very similar. It's becoming an automated area. It's almost pure robots, and we're even starting to see the advent of dark warehouses where you don't even need to turn the lights on because the robots are doing everything and the robots can see in the dark. So again, it's the low latency network. It's the ability to have thousands of devices connected on the network at the same time. It's the ability to have collaborative robots and drones working together. We have networks where the radio is actually on a drone and it flies over the truck, giving a bubble or a cone of high-speed coverage in a vast warehouse so that the truck below it can use that high-speed network to operate even though the rest of the factory isn't fully covered. So the applications that we're seeing in this that are being driven by our partners like Proximus are really amazing. It's terrific to see the ingenuity that people are bringing into this. The last area that we want to talk about is media and events. And I would strongly recommend everybody go to the demo down at the back wall just in front of the large stage. There's some really cool stuff there where you can see that when you're doing an outside broadcast, like I think it's called Wallyfest, as one example, but it is happening ubiquitously around the space now, that instead of bringing miles and miles or kilometers and kilometers of cabling with you when you have to do an outside broadcast or have to do any kind of an event, now the cameras are coming from the likes of Sony and Panasonic as 5G devices. They automatically know how to connect to a network. You can unload your van with your control panel, set up the cameras. You can even remotely control the cameras from your control station, so you don't even need a camera operator to run around with the camera anymore. You certainly don't need to have a camera operator another guy with a headset next to the camera operator who's talking to the control room, telling him what to film, and another person running after them, just literally carrying cable. That's what you still see at some sporting events, particularly in my own country, and it's ridiculous. Who wants to do that? Just put one camera out there, maybe with a camera operator, but also the communication to the camera operator can happen over the same private 5G network. So whether it is cable-free outside broadcast, whether it's critical communications at events, because you have security, you have all of the people that need, like our colleagues here in the AV department who are doing a terrific job, by the way, guys. They all need to talk to each other all the time. They need a network to talk on. You have point-of-sale devices. Research that we've done shows that if it takes longer than 8 seconds for a card-based transaction to go through, your chances of that transaction being abandoned go up to 50-50. So if you have gotten the concession to sell beer at a Bruce Springsteen concert, you've paid a lot of money for that. You need to make that money back by selling a lot of beer. Every time somebody says, nah, it's taking too long, I don't bother, I'll go get something else, I'll get a hot dog instead. You're losing money. So you need a network that means that all of those wireless point-of-sale devices you're walking around with can do the transaction super quickly so that you're not losing money. We're doing the point-of-sale devices for the US Open golf, and we'll be doing the Ryder Cup as well the next time it comes around. Ticketless entry. This is a new feature that we see a lot of stadiums, particularly when they have 50, 60,000 people all trying to come into the stadium at the same time or leaving at the same time. We're looking at projects in the States where your face is actually your ticket, particularly if you're a season ticket holder. The stadium knows who you are. When you come, they see you, they open the gate for you. We're also starting to see football stadiums concerned that the experience when you're in the stadium is now not as good as the experience if you're at home. Anybody who's a fan of Formula One will have known this for years. At home, you're watching all of the exciting things happening at the different turns, people overtaking, people spinning out. If you're live in the stadium, you sit there and then you hear a noise and people go, vroom, and then you sit there for another 10 minutes while something happens off in the countryside and you hear the roar of the engines and you wait for them to come by again and then vroom. You don't experience it at all. What football stadiums particularly are trying to do is to integrate a network where you can give augmented reality. So you look at the player through your camera before he takes a penalty and you can see his statistics for the last 10 penalties he's taken. Does he go left? Does he go right? What percentage is he likely to score? If you're looking at Mo Salah playing Liverpool, playing against Real Madrid last night, you would have said this is a definite score, but it wasn't, unfortunately. But the experience, making the experience for customers, also using potentially betting where it's legal, making the experience for consumers on site more interesting is all what this is about. And then you have the aspects of public safety and guest communications. I would encourage you to come by our stand and take a look at this, where we are using the video signal from the TV stations to feed this into virtual reality headsets for people who are 80, 90% blind, and allowing them to see football matches live, in some cases for the first time in 20, 30 years. It's a very moving video, and I think it's well worth taking a look at. This gentleman, Crystal Palace fan in the UK, Premiership Football Club, saw his team score a goal, and he turned to the guy next to him and he said, that's the first time I've seen them score a goal in 10 years. The guy next to him had perfect vision, and he said, yeah, me too. I haven't seen them score a goal in 10 years either, but that's their problem. I'm going to speak very quickly on Wi-Fi, or as we like to call it, why not Fi? Why don't we think you should do this with Wi-Fi? 3 reasons: capacity, control, and functionality. The spectrum that Wi-Fi is on just does not give you the range, the power, so you have to put more endpoints. You have to do more cabling to get to all of those endpoints. One of the projects we did for a large tractor manufacturer in the US replaced 200 Wi-Fi endpoints with 7 cellular endpoints. Then with all of your 200 endpoints, what's going to start happening? They're going to start conflicting with each other, so you have interference, and this is what gives you the timid tractor idea, where it gets to the edge of one Wi-Fi spot, doesn't trust the next one, doesn't move on, and just sits there. And this is because this is how it's designed, right? In the 2.4 gigahertz, there are only 3 unencumbered, uncontested channels in the whole spectrum. It's not doing it properly because it can't do it properly. It's not designed to carry the amount of traffic and the number of devices. And there's no way to make it work that I'm aware of. And you can say, yeah, Wi-Fi 6 and Wi-Fi 7, and it's much cheaper, but it's not much cheaper if you're putting 200 in for every 7 radios that you're putting in, and in 4 years' time, you're going to have to take it all down again. I'm being signaled to stop running over. Security and access to the network is much harder to manage in Wi-Fi, and in terms of functionality, there's nothing else out there that gives you network slicing, gives you ultra-low latency communication, can handle the massive machine-type communication and the enhanced mobile broadband that you need to deliver these use cases, which ultimately are all about one thing, and that is making you money. And in conclusion, this is only the beginning. What you do and what you see today in cellular for enterprise is going to be ubiquitous in a couple of years' time, and the things that are being talked about as research now are going to be standard in about 5 years' time. We would love to bring you, with our colleagues Proximus, on the journey with us. Thank you very much.
Proximus Next. Think possible.